Hi all, welcome everyone to our newest video. My name is Anas. I am a faculty of physics at Excel Educational Center. Today I am with a new chapter, electricity, a chapter from 10th grade science. Okay, before going to the questions, let's see some theory, a little bit of theory. What are we going to study in this chapter? We will be studying about the charge, the flow of charge and some phenomena associated with it. Okay, we have to understand what is a charge. I am going to represent an atom. This is the representation of an atom. Inside the atom, there will be nucleus. Inside the nucleus, there are some particles called protons and neutrons. Then there is another particle, electron, which is revolving around the nucleus. Right? Electrons will be revolving around the nucleus. I'm going to write these particles, proton, neutron, electron. These are the particles present in an atom. Some of these particles have a property called charge. So what is charge? Charge is a property of particles present in an atom. It can be of two types. There is two types of charges, positive and negative. Proton has a positive charge, electron will be having a negative charge. Then what is the charge of a neutron? Neutron does not have a charge. You can say neutron is neutral. Neutron is neutral, does not have a charge. It is a chargeless particle, right? Okay. Then let me ask you, what will be the charge of an atom? Charge of an atom also will be zero. Why is that? The number of protons and number of electrons will be equal. Equal number of positive charges and equal number of negative charges. They will be cancelling each other. So the atom will not be having a charge. Atom is neutral also. Then we have to see what is the smallest charge. What is the smallest charge? Smallest charge. The smallest charge is charge of one electron. Charge of one electron. There is a value for that. Let's study that value. Charge of an electron is a negative value, right? So minus 1.6 into 10 raised to minus 19 coulomb. What is this coulomb? Charge is a quantity. You can measure it. So there will be a unit. The unit of charge is coulomb. Unit of charge is coulomb. Okay. What is this? This is an object. An object. There is one extra electron on that object. We are placing an electron on that object. Now tell me, what will be the charge of this object? The charge on this object will be charge of one electron. One electron charge, right? If this object has two electrons in it, what will be the charge on this object? It will be 2 times the charge of an electron. Isn't it? Yes. If the object has n number of electrons in it, what will be the total charge of this object? The total charge of this object will be n times E. N times E. Now, this is the first equation we are going to study in this chapter. Q is equal to Ne. What is Q? Q is the total charge or net charge. Q is equal to Ne. Quantity of charge. Q is equal to Ne. What is this N and E? N is the number of electrons. E is the charge of one electron. If you do this, you will be getting the total charge or net charge of a body. Is that okay? Yes. Now, let's go to the next slide. What is it? Current. Current. You have to understand what is a current. What is an electric current? This is a conductor. A representation of resistance. We will study that later. Okay. Now, charge is passing through that conductor, flowing through that conductor in time t. What will be the charge in unit time? Unit time means 1 second. What will be the charge flowing through the conductor in 1 second? How to find that? How to find that using this equation? Using this equation, you can find the amount of charge flowing through the conductor in 1 second. This is current. What is this? This is current. I is equal to Q by T. That is current. How to write the unit of current? What will be the unit of current? Let's see. Unit of current, charge by time. You can write the unit of current like this, coulomb per second. Coulomb per second. That's okay, coulomb per second. And what is the SI unit of current? SI unit of current is ampere. Ampere, capital A is the symbol. Ampere, capital A. With what device you are going to measure current? You can measure current using a device called ammeter. Ammeter is a device with which we can measure current. This is the symbol for ammeter in a circuit. Symbol for ammeter. See that? Okay. Then ammeter has to be connected in series. Connected in series in a circuit. If you want to measure the current, you have to measure the ammeter. You have to connect the ammeter in series. Right? Okay. So what is current? That is the amount of charge flowing through a conductor in unit time. This is our second equation. I is equal to Q by T. I think we can move to the first question. Let's see. What is that? The amount of charge passing through a cell. What is a cell? Cell is a unit of battery. Positive terminal, negative terminal. This is a cell. Okay. Amount of charge passing through a cell in 4 seconds is 12 coulomb. So what is given? The charge is given. What is charge? Charge is given as 12 coulomb. What is the time? Time taken for the flow of charge, that is time T. T is equal to 4 seconds. It's given in the question. Find the current supplied by the cell. Yeah, you have to find the current supplied by the cell. What is the current? Then also find the number of electrons flowing. With what letter you are going to represent number of electrons? That will be N. What is N? So in this question you have to find current and the number of electrons. We have all the equations, right? How to find current? We have the equation I is equal to Q by T is the equation for the current. Right? Then what is Q? What is charge? What is charge? Charge is given as 12. So 12 divided by time. Time for which the charge flows. Right? That is 4 seconds. Then how to find the current? 12 by 4. What is the value of current? That will be 3 ampere. 3 ampere is the value of current here. Now, we found what is the value of current. We have to find what is N. What is the equation we are going to use? The equation for that will be Q is equal to NE. Right? Q is equal to NE. Quantity of charge is equal to N into E. Let's see what is N. N will be equal to Q by E. Q by E. What is Q? Q is given in the question. What is Q? Q is 12 divided by E. What is E? E. E is charge of electron. Charge of electron. That is minus 1.6 into 10 raised to minus 19 coulomb. It's a small value. But I will not be giving that negative sign in this equation. Can you tell me why? 1.6 into 10 raised to minus 19. I am not giving this negative sign. Why? We are going to find the number of electrons, right? Number cannot be negative. So you don't have to write this negative sign in this equation. Now, I'm going to teach you something. A little trick. 1 by 1.6. What is this 1 by 1.6? Remember, memorize the value. 1 by 1.6 is 0.625. Memorize that value. It will help you during the calculations. Okay. So 1 by 1.6 is 0.625 into 12. Into 12. Then this 10 raised to minus 19 is coming to the top. So into 10 raised to 19. This minus 19 will become plus 19. Okay. Now you have to multiply 625 with the 12. You will be getting 7500. Then you have to take 3 places. That will be 7.5. 7.5 into 10 raised to 19. So what is the number of electrons? Number of electrons will be 7.5 into 10 raised to 19. Tell me, what is the unit? What is the unit? Number, that's a number. Number does not have a unit. So you don't have to write the unit. Did you understand the first question? Yeah? Okay. Let's see the second topic. That is electric potential difference. It has another name. You know that with this name, voltage, electric potential difference is voltage itself. Voltage. What is that? I'm going to show you what is that. These two are 2 points, A and B. You have a unit charge. What is unit charge? Unit charge is plus 1 coulomb. That is a unit charge. You are bringing that unit charge from one point to another point. If you are displacing something, you may have to do a work there, right? You are doing a work there. You are doing a work there. You are doing a work on a charge. You are doing work on a charge. Work on a unit charge. That will become the potential difference between those points, right? That work done on unit charge will become the potential difference between those 2 points, right? So what is that? What is electric potential difference? That is the work done in moving unit positive charge from one point to another. Did you understand that? How to write the equation? So the equation will be V is equal to work done on unit charge. So the equation is this: V is equal to W by Q. What will be the unit? What will be the unit? Work has a unit joule. Joule per, what is the unit of charge? That is coulomb. Joule per coulomb is 1 unit. But what is the SI unit? We will be representing this with the volt. Capital V is the symbol. Did you understand what is electric potential difference now? Okay, then we can move to the next question. What is the next one? Calculate the potential difference between the 2 terminals of a battery. So you have to find the potential difference between 2 terminals of a battery. This is the positive terminal and the negative terminal. You have to find the potential difference. If 100 joule of work, so work is equal to 100 joule. 100 joule of work is required to transfer 20 coulomb of charge from one terminal of the battery to other. Transfer 20 coulomb. So what is the charge? Charge also is given, directly given in the question. That will be 20 coulomb. 20 coulomb. We have the equation. What is the equation? Equation for potential difference. V is equal to W by Q. Right? What is W? What is W? According to the question, it is 100 joule. 100 joule divided by Q. What is Q? Q is 20. 100 by 20. What is the voltage? Voltage will be 5 volt. That will be 5 volt. Yeah. So this is a simple question, right? A very simple question. Yes. Then Ohm's law. A very important topic in this chapter. Ohm's law. Let's understand what is Ohm's law. I am going to represent a conductor here. What is this? This is a conductor. Okay? Conductor. Current is flowing through the conductor. Current is flowing through the conductor. And these two are 2 ends of a conductor. Between these ends, there is a voltage existing. A potential difference is existing between these 2 ends. Okay. Then we have to give a condition for Ohm's law. There is a condition for Ohm's law. That is at a constant temperature. Right? You have to give that condition. Other than that, if there is no such condition, then Ohm's law will not be there. You have to give that condition. We will understand why we are giving that condition a little bit later. So what is that condition? At a constant temperature. You have to keep the temperature constant. At a constant temperature, the current flowing through a conductor is directly proportional to the potential difference between the ends of a conductor. That is Ohm's law. You can represent that using this relation. V is directly proportional to I. What is the meaning of this? What is the meaning of this? Current is directly proportional to voltage, or voltage is directly proportional to current. As the voltage increases, current also will be increasing. Understood? Right? This is just a relation. This is just a relation. You cannot do much about a relation. You have to convert that into an equation. How to convert this into an equation? You can remove this proportionality and you can give an equal to sign there. Then you have to multiply a constant with it. That will be R. So V is equal to IR is your equation. This is the equation for Ohm's law. V is equal to IR. Who is this V? V is voltage, I is current, then R. What is that? R is resistance. R is a constant called resistance. Resistance represented by R. What is that? What is that? Resistance. If you take a conductor and current is flowing through that conductor, there will be some opposition offered by this conductor to that flow of current. Right? Current flow will always be opposed by the conductor. So that opposition is termed as resistance. Then what is resistance? Resistance is the opposition offered by the conductor to the flow of current. Okay? What is the equation for resistance? You can have the equation for resistance from this equation. That will be voltage divided by current. This is the equation for resistance. Okay? What is the unit of resistance? Unit of resistance, voltage divided by current. So, unit can be written as volt per ampere. Okay. And we are representing that as ohm. Ohm. This is the symbol for ohm. So, this is about resistance. This is everything about resistance. Did you understand this? Okay. Now, let's see the graph of Ohm's law also. That also is important. The graph of Ohm's law is very important. I am going to represent voltage and current in a graph. Voltage and current in a graph. So this is voltage current graph. According to the Ohm's law, voltage is directly proportional to current. If you are drawing that, you will be getting a straight line. So Ohm's law will give you a straight line. It's a straight line. Voltage is directly proportional to current. As the voltage increases, current also will be increasing. Right? Now, that's a straight line. Straight line will be having a slope. Let's see what is the slope of this straight line. Slope. How to get the slope? I am going to create a small triangle here. This is y. This will be x. Okay. What is slope? Slope is y by x. I can write y by x. Y by x is slope. Right? What is y here? Y is a value of voltage. So I can write V there. Y is a value of voltage. What is current? Current. X. X is a value of current. Right? So I can write current instead of x. Then what is that equation? Voltage by current. Voltage by current is familiar. What is that? That is resistance. Right? So you can write slope is resistance. What is slope? Slope is resistance. Did you understand this? Slope is resistance. If you want to find the resistance from a VI graph, you just have to find the slope. Then slope will be equal to resistance. Everything is okay? Okay, then let's see the next question. What is that? Name and define SI unit of resistance. Yeah, SI unit of resistance. Name and define. What is the equation for resistance? R is equal to voltage divided by current. Right. What is the SI unit of resistance? That is ohm. So 1 ohm is equal to 1 volt divided by 1 ampere. Now you can define it. Now you can define it. Tell me what is 1 ohm. What is 1 ohm? 1 ohm will be the resistance of a conductor when 1 ampere current is passing through that conductor at a potential difference of 1 volt. Look at the figure. Look at the figure. What is 1 ohm? See, through this conductor, 1 ampere current is passing. Right? At the potential difference of 1 volt. Then the resistance of the conductor will be 1 ohm. Right? So what is 1 ohm? 1 ohm is the resistance of a conductor. Resistance of a conductor when 1 ampere current is passing through the conductor. passing through the conductor at a potential difference of 1 volt. How is this? Did you understand this? That is 1 ohm. Okay, then calculate the resistance of a resistor. So you need to calculate the resistance. Yeah. If the current flowing through it is 200 milliampere, current value is given as 200 milliampere. But there is a problem. The current is given in milli. You cannot do the calculation in milli. You have to convert that into ampere. How to convert milli into ampere? You have to multiply this value with 10 raised to minus 3. So milli is a number. That is 10 raised to minus 3. Multiply this value with 10 raised to minus 3. You can convert that into ampere. Right? What is this? 200 into 10 raised to minus 3. That is 0.2. 0.2 ampere is the value of current. When the applied potential difference is 0.8 volt, the voltage also is given. What is the voltage? Voltage is given as 0.8 volt. What is the equation? We have the equation. R is equal to voltage by current is the equation. Right? Then what is voltage? Voltage is 0.8 divided by current is 0.2. That will be 8 by 2. What is that? That is 4 ohm. Now I have the resistance value. What is the resistance? That will be 4 ohm. Okay. Did you understand this? Then let's go to the next slide. What is it? Factors affecting the resistance. We just found the equation for resistance. What is the equation for resistance? R is equal to voltage divided by current. Right? At the end of this topic, we will be getting another equation for resistance. Let's see. Which are the factors affecting the resistance? First one is length of the conductor. Length of the conductor. That means as the length of the conductor increases, resistance also increases. They are directly proportional. You can write it like this. R is directly proportional to length. As length increases, resistance increases. Then the second one. What is the second one? Area of cross section of the conductor. That is actually thickness. If the thickness increases, it will be very easy for the current to flow through that, right? Then resistance will be high. If the current is very smooth, then resistance will be very low. Understood? That means the thickness or area and resistance is inversely proportional. Inversely proportional. That means you can write it like this. Resistance is inversely proportional to area of cross section of the conductor. As the area of cross section of the conductor increases, resistance will be decreasing. Understood? Okay. The third factor is temperature. Temperature. We kept temperature constant when we were stating Ohm's law. Why is that? If the temperature is not constant, resistance will be changing. Then you cannot multiply that constant, that resistance with the current to get voltage. Right? Then there is no Ohm's law if the temperature is not constant. So temperature. As the temperature changes, resistance will be changing. Temperature and resistance of a conductor is directly proportional. If the temperature increases, the resistance also increases. Okay. Then the fourth one. What is the fourth one? Nature of material of the conductor. Nature of material of the conductor. Let's see. There is a conductor, copper. Conductor made of copper. This is copper. Copper. And there is another conductor having the same dimensions. Same dimensions means same length, same area of cross section of iron. Iron. Right? If you measure the resistance of these conductors, what you will be getting? You will be getting different values. One is copper, the other one is iron. So they will be showing different values of resistances. Then you can say the material is depending on the resistance. Clear? Okay. Now you can combine all these using this relation. R is directly proportional to L, inversely proportional to A. Okay. Just like we did before, we can remove this proportionality. Then you can give an equal to sign there, but you have to multiply a constant there. The constant we are going to multiply here is rho L by A. So you have an equation now. R is equal to rho L by A. Right? But we have to understand what is this rho. Rho is a constant. It's a constant. It's called resistivity. Resistivity. It's a constant for a particular material. Resistivity. That is rho. What is that? Resistivity. Let's write an equation for resistivity. Rho is equal to, you can bring A to the other side. Then it will be RA by L. That is rho. RA by L. This is the equation for resistivity. Understood? Equation for resistivity. Yeah. Then if you want to define resistivity, let's give L is equal to 1 unit length of a piece, unit length of a conductor. Then A is also taken as 1 unit. Then what is this equation? Then this equation becomes rho is equal to R. Now you can define what is resistivity. Tell me what is resistivity. Resistivity is the resistance of a conductor having unit length and unit area of cross section. Understood? What is that? If you take unit area and unit length of a conductor. Imagine this is copper. This is copper. You are taking unit area, that is length is equal to 1 meter. Unit length and unit area is equal to 1 meter square. If you measure the resistance of this material, resistance of this conductor, you will be getting R, that will be equal to resistivity. What is the meaning of that? Then resistance of this conductor will be resistivity of copper. What is that? Resistivity of this conductor will be, resistance of this conductor will be resistivity of copper. Did you understand this? This is resistivity. Let's find what is the unit of resistivity. Unit of resistivity. Look at the equation. R, resistance. Resistance has a unit ohm. What is the unit of area? Unit of area is meter square. Ohm meter square divided by length. What is the unit of length? Meter. Then meter square and meter is gone. Then there is only one m here. Now the unit is ohm meter. Unit is ohm meter. So the unit of resistivity is ohm meter. Did you understand this? Okay. Now let's see the next question. What is that? The figure below shows 3 cylindrical copper conductors along with their face areas and lengths. Compare the resistance and the resistivity of the 3 conductors. Justify your answer. Okay. There is A, B, C. 3 conductors. 3 pieces of conductors. Now, I am going to write the resistance of A. I can write it as RA. Resistance of A. What will be resistance of A? What is the equation for resistance? Equation for resistance is rho L by A. That is the equation for resistance. We know that, right? So, according to this equation, what is RA? RA is rho. Why there is only rho? Why there is no rho A or rho 1? Because every conductors are made of copper. So the resistivity of every conductors will be same. Rho for every conductors will be same. Understood? Okay. So rho, what is the length? L. So rho L by A. Area A. This is the first resistance. Rho L by A. Okay. Now find the resistance of the second conductor. Second conductor B. I am writing it as RB. What is that? That will be rho into length. What is the length there? Length there is 3L. Length of the second conductor is 3L divided by area. What is the area of the second conductor? Area of the second conductor is A by 3. Let's write that. A by 3. What happens to this 3? This 3 will be coming to the top. Then RB can be written as 3 into 3. 3 into 3 will be 9. 9 rho L by A. Right? What is rho L by A? Rho L by A is RA. That is RA. Okay? That means you can write it like RB is equal to 9 times RA. Yeah? There is a relation between RB and RA. Now, what is RC? Resistance of the third conductor. You can write the equation rho L by A. Rho is same, copper. Rho is same, rho L. What is L? L is L by 3. L by 3 by A. What is area? Area is 3A. 3A. How to do this? Take the reciprocal and multiply. What you will get? You will get rho L by 3 into 3, 9A. Who is this rho L by A? You can see a rho L by A in that equation. Rho L by A is RA. Now you can write RC as RA divided by 9. Yeah, there is a relation between RA and RC. RA divided by 9 is RC. Now what is the question? What is the question? Compare the resistance and the resistivity of the three conductors. How to compare the resistance of these conductors? What is the relation between the resistances? Which is the largest resistor? What is the largest resistance? Which is the largest resistance? RB. RB is 9 times RA. 9 times RA. And RC is RA divided by 9. RA divided by 9. So which will be the greatest resistance? The greatest resistance will be RB. RB is the greatest resistance. Right? RB is the greatest resistance. What about the next great resistance? Next large resistance? That will be RA. So I can write it like RA. RB is greater than RA and RA is greater than RC. Right? RA is greater than RC. So RC will be the least value of resistance. This is the relation between the resistances. Right? This is the relation between the resistances. Relation between the resistances. Okay. Now, what is the relation between resistivities? What is the relation between resistivities? I'll write it here. Relation between resistivities. Relation between resistivities. You already know the answer. Resistivities. Tell me the answer. What is the relation between resistivities? Resistivity of first one, second one, third one. Everything is same, right? Okay. That means you can write it like resistivity of A is equal to resistivity of B. That will be equal to resistivity of C. Why is that? Because every conductors are made of copper. The resistivity of them will be the same. Okay. Now, let's see the next one. Yeah, it's a good question. It's a good question. What is that? There is column A, column B. In column A, there are some quantities. Column B has some units. You have to match them. You have to match them. What is electric potential difference? Electric potential difference is voltage. Voltage is work divided by charge. Is the equation for voltage, potential difference. What is the unit of that? Unit of voltage is volt. Capital V is the symbol, isn't it? Right? Okay. Now, electric potential difference. What is the unit? Unit is volt. Unit is volt. That means you can match A to 2. You can match A to 2. Then resistivity. What is the resistivity? Unit of resistivity is ohm meter. You just studied that, right? Unit of resistivity is ohm meter. Then there is resistance. That's very simple. What is the resistance unit? Unit of resistance is ohm. Then there is electric charge. What is that? What is left? There is only coulomb left. Charge has a unit of coulomb. Right? Okay. Now A is mapped to 2. B is mapped to 4. Like that. Which is the correct one then? A is mapped to 2, B is mapped to 4, C is mapped to 1, C is mapped to 1, then D is mapped to 3. Yeah, which is the correct option then? The correct option is D. Right? The correct option is D. Okay. Now let's see the next question. Yeah, it's an MCQ. It's an MCQ. Yeah. I saved the MCQs and assertion questions, assertion reason questions for the last. What is that? A cylindrical conductor of length L and uniform area of cross section A has a resistance R. Okay. I'm going to write the equation for resistance. What is that? Equation for resistance is rho L by A. Yeah, rho L by A. Yes. Another conductor of length 2.5 L. So we have another conductor. I'm going to give the length of the second conductor as L dash. Because it's another length, so L dash. L dash is 2.5 times our old length. And resistance of the second conductor also is given. I'm going to write it as R dash. What is R dash? R dash is given as 0.5 R. Yeah, okay. Of the same material. Of the same material means resistivity is same for both of these conductors. If one is copper, the other one also is copper. Okay, has area of cross section. You can write the area of cross section of the second conductor as A dash. What is A dash? That is the question. What is A dash? That is the question. What is the equation for A from the first equation? A is equal to R is, you can bring A to that side, R to this side. Then what happens? Then there is already rho L here. Rho L divided by R will be the equation of area. How is this? Equation of area, that will be rho L divided by R. Then what will be the equation of A dash? Equation of A dash is rho L dash divided by R dash. Right? Okay. Rho is same. So rho L dash by R dash. Then what is A dash? Rho into L dash. L dash is 2.5 L according to the question divided by R dash is 0.5 times R according to the question. Then you can cut this 2.5 and 5, that is 25 by 5. What is it? That will be 5 here. Then A dash is equal to rho. Now, there is a 5 here. So, 5 rho L by R. What is this rho L by R? Rho L by R. Rho L by R. Yeah, that is A. Rho L by R is A. That means our A dash, new area, that is 5 times the old area. New area is 5 times the old area. So, which is the correct option? Which is our correct option? The correct option is this. Look at that. 5A. Right? Okay. Let's go into the next question. What is that? A student plots VI graph for 3 samples of nichrome wire with resistances R1, R2 and R3. Okay. Choose from the following statement that holds true for this graph. Yeah. We have seen the graph for Ohm's law. Right? We have seen the graph for Ohm's law. Now this is current voltage graph. Current voltage graph. It is starting from 0. This is R3. Resistance R3, R1, R2. Yeah, okay. Before answering this, I am going to redraw this graph here. I am going to redraw the graph here. Current on the y-axis, on the x-axis, voltage. We just saw Ohm's law graph like this. Voltage on y-axis, current on x-axis like this. Right? Then what was the slope there? The slope was voltage divided by current. That was resistance. Right? Okay. If the slope is high, the resistance will be high in that case. Here, I is on the y-axis and V is on the x-axis. The graph will be straight line. Why is that? Because current and voltage are directly proportional. That's why. Current and voltage are directly proportional. So the graph will be a straight line. Yes. Now, what is the slope of this graph? Slope of this graph. Slope is always y by x. Isn't it? Y by x. What is y here? Y is a value of current. What is x? X is a value of voltage here. Current divided by voltage. Which is this quantity? Current divided by voltage. Definitely not R. Because resistance is voltage by current. Then current by voltage is reciprocal of the resistance. It's actually conductance. Reciprocal of the resistance. See that? Reciprocal of the resistance. What happens? What happens in this graph? If slope is high, resistance is low. Understood? If slope is high, resistance is low. I can write it like this. Slope and resistance are inversely proportional. Inversely proportional. Then there is R3, R1 and R2. Okay. Which is having the largest slope. R3 is having the largest slope. That means the resistance of R3 will be the least. Right? Okay. Which has the greatest resistance, which has the least slope. Who has the least slope? R2. So you can write it like this. Slope of R2 is the least. Slope of R2 is least. Then slope of R1. Right? It is greater than slope of R3. Greater than slope of R3. Right? Like this. What about the resistances? If slope of R2 is the least, what is the meaning of that? Resistance of R2 will be the greatest. R2 is the greatest. Then R1. Then R2 is the greatest. Then R1. What is the least resistance? That will be R3. Right? Okay. This is the correct relation. Look at the options. R1 equal to R2 equal to R3. Definitely not true. That is not our option. Yeah, that's not our option. Then R3 is greatest. No, that's not it. R1 is greatest. No. So what is our answer? Our answer will be D. R2 is greater than R1, which is greater than R3. So this will be our correct answer. Right? Okay. So that's it. Let's see the next one. What is it? Yeah, it's an assertion reason question. Read the assertion. What is that? What is that? When the length of a wire is doubled, then its resistance also gets doubled. That's the assertion. Let's try that. What is happening here? The resistance R can be written as rho L by A. Isn't it? Rho L by A. Okay. If you are stretching that wire, it's a wire. It's a wire. Resistance of a wire can be written as rho L by A. If you are stretching that wire to double its length, the new length can be written as L dash. L dash is equal to 2 times L. Right. Okay. What happens to the area if you are stretching it? What happens to volume if you are stretching it? Volume will not be changing. If you are cutting it and you are removing it, then the volume will be changing. Otherwise, there is no change in volume. So the main idea is volume is a constant. Volume is not changing. If volume is not changing, old area into old length will be equal to new area into new length, isn't it? Right. From this, you can find a new area. Okay. Then area into length is equal to new area into new length. What is the new length? New length is 2 times old length because it has doubled, right? Okay, then this length L can be cut. What is A dash? A dash will be A by 2. A dash becomes A by 2. From this, you will understand if length doubles, area becomes half. Why is that? Why it is happening so? Because volume is a constant. Right? Okay, so A dash becomes A by 2. Length becomes double. Length doubles, area becomes half. Then what will be the new resistance? What will be new resistance? Let's see the new resistance. You can represent that with R dash. What will be R dash? R dash is equal to rho L dash divided by A dash. Why rho? Why not rho dash? Because the material is not changing. That's the same material. Rho L dash by A dash. That is R dash. R dash is equal to rho into L dash. L dash is 2L divided by A dash. A dash is A by 2. How to do this? Take the reciprocal and multiply. If you take the reciprocal and multiply, R dash is equal to 2 into 2. That will be 4 rho L by A. Who is this? Rho L by A. That is our old resistance. That's our old resistance. Now you can write R dash is equal to 4 times R. What is that? R dash is equal to 4 times R. What is the meaning of this? If you stretch the wire and the length of the wire is doubled, then the resistance becomes 4 times. Resistance is not doubling. Resistance becomes 4 times. Did you understand this? Okay. That means the assertion is wrong. This is wrong. Clear? This is wrong. Assertion is wrong. Now, what about the reason? The resistance of a wire is directly proportional to its length. We just saw that. It's right? Okay, so resistance is directly proportional to length of the conductor. That is okay. That means the sentence is true. That is true. Okay, this sentence is true. Okay, that is our 8th question. Yeah. Now let's move to the last question. What is that? Read it. The current is the rate of flow of charge. I am going to write the equation for current. Equation for current, I is equal to Q by T. This is the equation of current, isn't it? This is the equation of current. Now, whatever may be the quantity is, if you are dividing that quantity with the time, you will get rate of that quantity. You will get rate of that quantity. So, this equation is charge divided by time. Actually, the current is rate of flow of charge. Right? You can write it as rate of flow of charge. Okay. Now, that makes the assertion true. That makes the assertion true. Assertion is true. Yeah. Okay. Then read the reason. Electric current will not flow between two charged bodies when connected if they are at the same potential. Let's see that there is one body here, another body here. There is a connection between these two bodies. Yeah, you can see that there is a connection between these two bodies. The first body is A, second body is B. Okay. And according to that reason, potential of A and potential of B are same. I am writing potential of A as VA. Potential of B is VB. According to the question, what is that? VA is equal to VB. Yeah, VA is equal to VB. Electric current will not flow between two charged bodies. Huh? What is that? Yeah, you have to understand how the current is flowing through a conductor. Current has needs two conditions to flow. First one, it needs a closed path. Current needs a closed path, right? Current needs a closed path. That is the first condition. The second condition is there should be a potential difference. Then only the current will be flowing. Okay? There should be a potential difference. Like this. I'm going to represent a circuit here. This is a circuit. Yeah, R here. It's a cell, battery, switch. Now, if the switch is on, the current will be flowing out of this positive terminal to the negative terminal. Current will be flowing out of positive terminal to the negative terminal. Why the current is flowing? Because there is a closed path. You can see that there is a closed path there. Not only that, there is a battery. That battery is maintaining that potential difference there. That's the function of the battery or cell. It's keeping the potential difference there. Only if there is a potential difference, the current will be flowing. Okay, now back to our question. There is A and B. Potential are same. The potential of A and potential of B is same. That means if the potential is same, there is no potential difference. If there is no potential difference, the current will not be flowing. Did you understand that? So what is that? Electric current will not flow between two charged bodies. Even if they have the charge, their potential is same, then the current will not be flowing. when connected, if they are at the same potential, that makes reason true. That makes reason true, right? So assertion is true, reason is correct, but reason is not the correct explanation for assertion, right? It's not the correct explanation for assertion. So that will be our answer. Assertion is true. Both the assertion and the reason are true, but the reason is not the correct explanation for assertion. Current is the rate of flow of current, rate of flow of charge. That's the assertion. So this is not the reason for that. Okay. So this is the end of our discussion. We have discussed this chapter up to almost half of the chapter. Then we will continue our discussion in the next video. We will complete this chapter in that next video. Until then, bye. See you later.